In this video, we're going to focus on calculating the linear regression equation. Here are some things that you can know about regression. Its relationship between two sets of data that can be represented by a linear equation called a regression equation or linear regression. Big thing you need to make sure is that you identify correctly the independent and dependent variable. So dependent and independent variables. Regression equation can be constructed as your line of best fit. So we've already kind of talked about scatter plots, finding that line of best fit using the mean point and above and below the line. We've talked about point slope form. This is a more accurate measure of their line of best fit using this regression equation. So the equation looks like this. Y equals alpha, which represents your y-intercept, plus beta, which represents your slope, and then x. Here is the formula set that you should write down, this entire box. This will be how you calculate the slope, and this will be how you calculate the y-intercept. So please write this down and pause. And then we'll go through what each of these things mean. This represents the sum of the product of x times y. This represents the number of items in the data set. This represents the mean of x, the average of x, and the average of y. This represents the sum of the x squared terms. Again, there's your number of terms in the element, and then your mean of x squared. All right, and then again, this is your y mean, and then this is your slope, and then your x mean. Okay, so I just kind of talked through that, kind of messy here, but all right. Here are some things that you can know about linear regression that are down here. The slope of a line depends on whether the correlation is positive or negative. So remember that positive slope, positive correlation, or negative slope, negative correlation. A regression equation can be used to predict dependent variables from independent within a range of scatter plots. It should not be used to predict x given y or to predict outside the bounds of the given x values. So remember when we talked about interpolation and extrapolation? Extrapolation is what we're talking about, those going outside the given x value. So make sure you understand this here. The stronger the correlation between the two variables, the better prediction made by that regression equation. So you can make predictions about your x values. Alrighty, so let's move on. We're going to do an example. Calculating the correlation coefficient for the height and weight by finding the linear regression equation. So what we're going to do is we're going to give you a set of weights and heights for some people. So you have your independent variable is your height, and your dependent variable is your weight. So we've listed it out here. Go ahead and pause and write down this information. All right, again, this is your height, this is your weight, and there are two more things you have to find in order to start using the formulas. You have to take x squared and x times y. So this is going to take a little bit of work, so let's start here. You're going to take 167 and square it. 178, square it. 173, square it. And continue on. If you want to pause and check your answers, you're welcome to do so. right, we're taking care of the first task of squaring the x values. Now, in the next column, we're going to multiply the x times the y. It'll continue with all the values. Again, I'm multiplying x times y. Okay, so give yourself a moment and go ahead and enter those in. All right. Now what you need to do is you need to sum those columns together. So you're going to add the first column. So to save us a little bit of time here, I'm just going to go ahead and take these numbers, 1697 and 563. You can look at this later, 1697 and 563. Then again, we'll take these two numbers. And write them down. It'll save us a little bit of time with our calculator right now. Okay. So we finished that setup. Now we're going to go ahead and start to do some calculations with the means of x and y. So here is your sum of x, that first column. Remember to find the mean. You add the x values and you divide by how many items you have in your data set. So we have 10 people in our data set. You can count them off if you want to, okay? Then you would do the same thing with your mean of y. So 169.7 is the mean of x, and 56.3 is the mean of y. Now we're set to go ahead and start to use our formulas that was on that previous slide. We're going to find the b first, which is your slope. So we're going to use this formula here, and we're going to start to plug things in. All right, so first thing we have to do is we have to go up to our chart and find the sum of x times y. That's right here, 96238. 96238 minus n, which is 10 people in your set, then the mean of x times the mean of y. So the mean of x times the mean of y. All over. I'm just going to change colors here. What this represents is the sum of x squared. So that's up here, 288,627, 288,627 minus n, which again is 10 people in your set of people you found. And then this last piece, be careful with it. It's saying take the mean and square it. So if we head back up here, here's our mean of x, and what we're going to do is we're going to square that number. So 169.7, and we're going to square it. All right, now the rest is using our calculator. So 96,238 minus 10 times 169.7 times 56.3. All right, so in the numerator we get 696.9, and in the denominator we divide those two numbers. All right, so this represents our slope. Next, we're going to find our y-intercept. So to find our y-intercept, we take our mean of our y, which was back up here, the mean of the y, 56.3, minus our slope, right here, 1.0786 times the mean of x. And here's our mean of x, 169.7. All right, we're almost there. So go ahead and use your calculator again. And we get a value of negative 126.73. This is your y-intercept. Now, what you do is you take your slope and your y-intercept and you plug it into this equation. So y equals your y-intercept, negative 126.73, plus your slope, 1.0786 x. I personally like to write my slope first. So 1.0786, positive slope. So that means I have a positive correlation. All right, and then again, I did put this up here for you, so if you wanted to see it worked out a little nicer than my writing, you can go ahead and do that.